Alright, 6.3, day number 3. Let's talk today about finding the volume using cross-sections perpendicular to an axis. Let's jump into it. Alright, I'm going to graph the following situation in a couple different ways. One of them will give a little bit better perspective on what it's actually going on here. But this function, y equals 1 minus x squared over 4, when x is 0, y will be 1. When y is 0, x will be 2. Okay, now this graph will look kind of like that, but we're not revolving it this time. So I'm going to sketch with a different perspective. Here's my y-axis. Here's my x-axis. Here's y equals 1. Here's x equals 2. Okay, now what we're doing is we're creating squares, and those squares are driven by these lengths right here. Okay, and each of these squares, right, this length, this blue length drives a second blue length, which creates a square. The green length does the same. The yellow length as well. And the black length. So we're creating this interesting three-dimensional solid that's based on a square. Alright, so what we'd have here is the integral from 0 to 2 of whatever our y value is. Each of these here are y values. Right, each of those lengths are y values. And we're going to square them. So the integral here would be from 0 to 2 of y, which is 1 minus x squared over 4 dx. As simple as that. That's a square. Alright, so I'm going to take this thing y and I'm going to square it. What if each of these were rectangles? Well, then it would be whatever the y value is. Let's say the height of the rectangle was 3 times the width, then I'd multiply it by 3y. Right? That's just a rectangle, base times height. A square is side times side. Right? A rectangle would be base times height. So we've got some work we can do. I would type this in here for y1 and take the integral from 0 to 2 of y1 squared. Yep, that should be squared. Almost forgot that. In terms of x. And my calculator is giving me a volume of 1.066 units cubed. Alright, that is volume of perpendicular cross sections there. That'd be it for chapter 6, so onward we move.